Imagine you've got a wonderful physics problem, and you have to solve it by computation. You implement your equations in a wonderful simulation and you run it into a wonderful computer. Then you write the results in a wonderful structured database. So what?
You cannot write incredible articles or even take conclusions from your own research without some great plots. But putting data is not always as easy as writing a simple plot in Python. The easiest way to plot the data is by using the PTK libraries that allows us to create an object that contains all the geometry of the mesh and all the quantities related to it. Bigger tools for them. Once done, we will open the resulting paraview. This is quite a good software for that kind of visualizations. We can just open the PTK, but if we want to interact with it, if we want to process the data, we need to go further. We need to create a custom interface inside paraview, which takes some input from the user, runs some code behind the scenes, and then plot the result again on the screen. Do you want? Yeah. So we have to create a plugin, which will use both paraview and PTK functions to do what we want. We have already talked about how we create those plugins, how we do it in Python, and what are some advantages versus doing it in C++. Now let's demonstrate with a simple example the usage of our plugin generator.
Yes, we've got a folder with our plugin generator, but we need to write a script that tells the plugin what to do. Let's just define a function inside that prints something on the screen. It will take all of these arguments and perform something with them. First, let's say hello to you. Then let's print some stuff. Now we choose one color by its index from a list, and finally we will print something related to the boolean variable. Let's move now to our plugin generator. We import our function here and fill some simple stuff. Now we go to the next part, where we will create the interface. We add our function and a field for name and surname. Then a drop-down list for colors, another field to fill for the first tint. The second tint will be a slider. Now we'll add a hidden bool and a button to refresh, and also a new category to sources that will make easier to find our plugin on paraview. Then we run the script and a new XML will be created. Now we'll move ourselves to paraview and then just load the plugin. Then we open it from sources, set up the parameters, also the bool, and run. It works.
Let's see now how our big plugin works.
First of all, we import our plugin as we will do with any other else. A new category will appear in Sources tab, where we can find our 4 new tools. Let's work first with the main one. Those fields are just to tell the script where in the database to search the data. Once filled, we press apply, and after less than a minute, data will be displayed on the screen. Our object is divided in multiple blocks, and we can select as many as we want for the visualization. Many of the blocks are just lines, so it would be interesting to track over time the value of the scalars in the whole line, making some 3D plots or contour plots. If we press apply with list 999, a list with all the linear blocks will appear here, so we can choose the one we want to track. Also, if we want to track a single point, we get its ID from paraview and type it here. If we mark those two fields, two TXT files will be created with the data we need for the plots, so let's do it and run the program again. Now, if we select the track one point tool, we will see its evolution through time. We can also choose what quantity we want to track in the properties panel. Unfortunately, this dataset doesn't hardly change through time, so we can continue the demonstration with another one.
In fact, it's not easy and it takes quite a long time to produce those datasets, so we have no perfect object for the demonstration. The one I'm about to show you now is composed by a single block, but we can still define a line to read and repeat the procedure with the same tools.
Okay, this is the same linear plot, much more interesting now. If we load the 3D tool, we'll visualize a 3D representation of the evolution of the line that we are tracking in both spatial and temporal axes. Here we have some properties that we can change, like the scalar we want to track, the coloring, the position of the camera or the resolution. Sometimes, if the data varies too much, a 3D plot can be too loaded to see things clearly. For those cases, we have created the fourth tool, which displays a contour plot where the evolution of the subset is much easier to see. One little detail is that although it works fine in paraview, the magnitude that we are using inside is much more limited than the real one, so our plots are a bit restricted too. that's not a problem. In fact, that's the reason why we have created the 2txt files with data for the plots. We can use Paramount to process the data, deal with the blocks or visualize the some previews, and then make the definitive plots outside in the real manual